Hey guys, welcome to Unit 5. This is going to be trigonometry. So I'm going to start with taking a couple of notes. There's going to be a little bit of writing here. And then we'll go on to working a couple of examples. So first, let's define the word trigonometry. Trigonometry is a branch of mathematics which revolves around the study of relationships involving lengths and angles of triangles. All right, so on number 2, we're going to draw a diagram of a right triangle. And label everything, all the important parts. So obviously this is where we would have a 90-degree. I'm going to put just a little angle here. We may know the angle measure, we may not. And I'm going to put that here. So this will represent an angle measure. It's either going to be missing or given. And you'll see several examples of both. And then this is going to be our opposite. This is always going to be the hypotenuse. And then this will be our adjacent. All right, so let's talk about SOHCAHTOA. I know that you guys have had quite a bit of experience with SOHCAHTOA. The SO is always going to be sine, which is represented by this on the calculator, and it's always going to be equal to opposite over hypotenuse, which for those of you who are behind, maybe the S represents like sine, cosine, or tangent, obviously sine for us, and then OH represents what we'd put here, so SOH. So then we have cosine here, which is written as cos, and then the A over H, which would be adjacent over hypotenuse. And then we have TOA, tangent. The tan of the degree is equal to opposite over adjacent. All right, now down here, let's talk about reciprocal functions. This is going to be cosecant. Which is represented by CSC. And this is going to be the opposite. It's going to be hypotenuse over opposite. All right, and then over here we will have secant. Secant of the angle is again going to be the reciprocal of cosine, which will be hypotenuse over the adjacent. You're flipping the fraction. And then we have cotangent. And again, the opposite, so it'll be adjacent over opposite. All right. In your own words, describe what a reciprocal function is, and then write down the reciprocal function. So as I already stated, these bottom ones, cosecant, secant, and cotangent are always going to be your reciprocal functions. Cosecant, which is CSC of the angle, 1 over sine. All right, this is just another way of writing it. And because 1 over sine is what makes the fraction then flip. So then we have secant, which is SEC of an angle measure, which is equal to 1 over cosine of that angle measure. And I will put that there as well. And then we have cotangent, equal to 1 over tangent of the angle measure. All right, and then just to describe it in words, we have cosecant, secant, and cotangent. These are all the reciprocal functions. Okay, if sine of an angle measure is opposite over hypotenuse and cosine is adjacent over hypotenuse, what does sine over cosine equal? And so, show work on how you reduce. Okay, so for the first one, we are given sine over cosine. Okay, which if we were to write this out, sine is opposite over the hypotenuse. That's just sine over cosine, which is adjacent over hypotenuse. All right, when we're writing it like this is the same as writing opposite over hypotenuse divided by adjacent over hypotenuse. We would then flip the second fraction to multiply. And this is just showing you how we get certain things, and it'll make a lot more sense. So I'm going to flip this one and multiply. It'll be hypotenuse over adjacent. And look, we multiply these, we can cross out the hypotenuse. So technically, sine over cosine is equal to opposite over adjacent. Oh, and that should be a J. That's my bad. Opposite over adjacent is also equal to what? Tangent. Opposite over adjacent. Tangent. So, I ran out of room. So this also tells us that tangent is equal to sine over cosine. We're going to simplify the next one. So we have cosine over sine. So if we take and this is actually adjacent over hypotenuse divided by sine, which is opposite over hypotenuse. Okay, then we would rewrite this. I'm going to go ahead and skip the step where I wrote it as division, and I'm going to go ahead and flip the second one and write it as multiplication just to save some room. So this would technically be adjacent over hypotenuse divided by opposite over hypotenuse, but I'm going to go ahead and flip it and write hypotenuse over opposite and cancel out. So we get adjacent over opposites is technically cosine over sine, adjacent over opposite. Which one is also adjacent over opposite? Cotangent. So cotangent is equal to cosine of an angle over sine. Okay, this is us simplifying. All right, what identities did we just prove? Well, we proved tangent and cotangent. These are called quotient identities. All right, so this is all basically going over a proof of how SOHCAHTOA is all connected to each other and how you can use them to solve for other parts of a triangle. So let's move on to the second part of this one. All right, there are two special right triangles that we will deal with regularly in trigonometry. These are both going to be on your homework today. So we have 30, 60, 90 triangles and then 45, 45, 90 triangles. You will not be able to use it on any other types of triangles. These are special right triangles. So here are the lengths of the legs for the 30, 60, 90. You have the hypotenuse is always going to be 2x, and then we have the legs as x, and then x to the square root of 3. All right, so you will need to keep this in mind as you are working. This triangle as well as this one are going to be very helpful while you're working on your homework assignment, because sometimes they just would give you the hypotenuse. Then you would know that opposite leg would be just like half of the hypotenuse, right? And then this would become, if this were like 16, then this would be 8, and then this would be 8 to the square root of 3, and then that would give you all of those legs. So knowing one can help you solve for the rest, as long as you know how the formulas work for the legs of the triangles. All right, and then the 45, 45, 90 is a lot simpler to me because both of your legs are going to be the same, and then your hypotenuse would be that leg length to the square root of 2. All right, so then if you had, if your x was 10, then it'd be leg 10, and then 10 to the square root of 2 would be the hypotenuse. All right, if we know two sides of a right triangle, can we find the measures of the angles and is it a unique solution, only one solution? What if we know the measures of all three angles? Can we find the lengths of the side? Is it a unique solution? All right, so if you know two sides of the right triangle, then you're only going to find one solution. There's only going to be one possible solution for the third. However, if you know all three angles, the solution is not unique, which means there could be several different answers. However, if you're given two sides of a right triangle, there's only ever going to be one unique solution. All right, define angle of elevation and angle of depression. Draw a diagram to support your definitions. I went ahead and drew the diagrams just to save us some time. This one here is going to be the angle of elevation. And this one over here will be your angle of depression. What I can tell you about both of these, the depression and the elevation, I'm trying to shorten my words here, they are congruent. And this will help you in cases where they give you the triangle and they give you like an outside and exterior angle measure. You can know that these are alternate interior angles and that they'll be equal. Hopefully you guys remember alternate interior and alternate exterior angles from before, previous classes. So define what it means to solve a triangle. So if they are telling you to solve a triangle, that means you're finding all three angles, like you're completing the triangle. You're going to find all three angles and all three sides. So you'll find every angle measure and every side measure of the triangle. All right, using the information you gathered, find the solutions to the following right triangle questions. I will always tell you to draw a triangle here. No matter what, there's nothing more helpful than a picture to help you get a good understanding of what you're looking for. So we have if cosine, and I went ahead and drew the other ones, but I wanted to wait and do this one with you. Cosine of an angle measure is 6/7. Find the other 5 trig ratios. Write your answers with denominators rationalized. All right, so let's go ahead and draw our triangle, and then this is going to be our little angle measure. And then if we're talking about cosine, that is adjacent over hypotenuse. That means that our hypotenuse is 7, and then that our adjacent is 6. All right. Here we go. To find that other angle measure, we can do a squared plus b squared equals c squared, which in our case would be a squared plus 6 squared is equal to 7 squared, becoming 49 minus 36. We subtract 36 from here. We get that a squared is equal to 13. So our other measure here will be square root of 13. Please do not forget that anytime you get a value squared is equal to 13, that you square root it. So a is equal to the square root of 13. Okay, so here we're just finding the trig function. So we have sine, which is so, right? That would be opposite over hypotenuse. We would have square root of 13 over 7. We already have cosine, they gave it to us. Tangent, TOA, is gonna be opposite over adjacent. All right, and then we have cosecant, which is gonna be 7 over the square root of 13. We're going to multiply that by the square root of 13, bottom and top, to get rid of the square root in the to rationalize the denominator. So we would end up getting 7 to the square root of 13 over 13. All right, and then we have secant, which is going to end up being 7 over 6. Because it is the opposite of cosine, so we just flip it there. We did the same thing with cosecant, however, we had to rationalize the denominator, so we ended up getting rid of the square root of 13 as the denominator. And then we'll have to do the same thing with cotangent, because we end up getting 6 over the square root of 13. And if we multiply both by the square root of 13, then we get 6 to the square root of 13 over 13. All right, so all I'm doing for the reciprocals is I just flipped it and then I rationalized it if I needed to, if there was a square root in the bottom. All right, if the hypotenuse of the triangle measures 54 and the side adjacent to the given angle is, or to the given angle of whatever this is, right? We don't know what that is technically. In the triangle measures 36 inches, find the measure of the of this angle is all we're looking for. So we know cosine of that angle is technically 36 over 54. All right. So in order to find this angle measure, we would have to basically do cosine to the -1, which is actually going to be, where is it? The cosecant. It's the same as the cosecant. But we will end up putting cosecant of 36 over 54 into the calculator, which is going to give us 48.19 degrees. All right. Here we're finding an angle measure. They actually gave us this. This makes it a little bit easier to do. So we know that sine of 18, if we're looking at which is opposite over hypotenuse, sine of 18 is equal to 22 over x. This is why your SOHCAHTOA is so important. So then we get x, sorry guys. If I were to multiply both sides by x to get it out of the denominator, I would get x times sine of 18 is equal to 22, and then divide this side by sine of 18, divide this side by sine of 18. That means x is equal to 22 over the sine of 18, which is going to give me 71.19 centimeters. All right, and that's part 1.